Hey everyone, this is Reshma from Edureka, and today we'll be learning what is Ansible. First, let us look at the topics that we'll be learning today. Well, it's quite a long list. It means we'll be learning a lot of things today. So let us take a look at them one by one. So first, we'll see the problems that were before configuration management and how configuration management helped to solve it. We'll see what Ansible is and the different features of Ansible. After that, we'll see how NASA has implemented Ansible to solve all their problems. After that, we'll see how we can use Ansible for orchestration, provisioning, configuration management, application deployment, and security. And in the end, we'll write some Ansible playbooks to install LambStack on my node machine and host a website in my node machine. Now, before I tell you about the problems, let us first understand what configuration management actually is. Well, configuration management is actually the management of your software on top of your hardware. What it does is that it maintains the consistency of your product based on its requirements, its design, and its physical and functional attributes. Now, how does it maintain the consistency? It is because the configuration management is applied over the entire life cycle of your system, and hence it provides you with very good visibility and control. When I say visibility, it means that you can continuously check and monitor the performances of all your systems. So if at any time the performance of any of your system is degrading, the configuration management system will notify you, and hence you can prevent errors before it actually occurs. And by control, I mean that you have the power to change anything. So if any of your servers failed, you can reconfigure it again to repair it so that it is up and running again, or you can even replace the server if needed. And also, the configuration management system holds the entire historical data of your infrastructure. It documents all the snapshots of every version of your infrastructure. So overall, the configuration management process facilitates the orderly management of your system information and system changes so that you can use it for beneficial purposes. So let us proceed to the next topic and see the problems before configuration management and how configuration management solved it. And with that, you will understand more about configuration management as well. So let's see now, why do we need configuration management? Now, the necessities behind configuration management was dependent upon a certain number of factors and certain number of reasons. So let us take a look at them one by one. So the first problem was managing multiple servers. Now, earlier every system was managed by hand. And by that I mean that you have to log into them via SSH, make changes, and then log off again. Now imagine if a system administrator would have to make changes in multiple number of servers. You'll have to do this task of logging in, making changes, and logging off again and again repeatedly. So this would take up a lot of time, and there is no time left for the system administrators to monitor the performances of the system continuously. So if at any time any of the servers would fail, it took a lot of time to even detect the faulty server and took even more time to repair it, because the configuration scripts that they wrote was very complex and it was very hard to make changes onto them. So after configuration management system came into the picture, what it did is that it divided all the systems in my infrastructure according to their dedicated tasks, their design or architecture, and they organized my system in an efficient way. Like, I've grouped my web servers together, my database servers together, application servers together. And this process is known as baselining. Now let's, for an example, say that I wanted to install LambStack in my system. And LambStack is a software bundle where L stands for Linux, A for Apache, M for MySQL, and P for PHP. So I need these different softwares for different purposes, like I need Apache server to host my web pages, I need PHP for my web development, I need Linux as my operating system, and MySQL as my data definition language or data manipulation language. Since now all the systems in my infrastructure is baseline, I would know exactly where to install each of these softwares. For example, I'll use Apache as my web server here. For database, I will install the MySQL here. And also it became easy for me to monitor my entire system. For example, if my web pages are not running, I would know that there is something wrong with my web servers. So I'll go check in here. I don't have to check the database servers and application servers for that. Similarly, if I'm not able to insert data or extract data from my database, I would know that something is wrong with my database servers. I don't need to check these two for that matter. So what configuration management system did with baselining is that it organized my system in an efficient way so that I can manage and monitor all my servers efficiently. Now let us see the second problem that we had, which was scaling up and scaling down. See, nowadays you can come up with requirements at any time, and you might have to scale up or scale down your systems on the fly. And this is something that you cannot always plan ahead. And scaling up your infrastructure doesn't always mean that you just buy new hardware and just place them anywhere haphazardly. You cannot do that. You also need to provision and configure these new machines properly. So with configuration management system, I've already got my infrastructure baselined. So I know exactly how these new machines are going to work according to their dedicated task and where should I actually place them. And the scripts that configuration management uses are reusable, so you can use the same scripts that you use to configure your older machines to configure your new machines as well. So let me explain it to you with an example. Let's say that if you're working in an e-commerce website and you decide to hold a mega sale, a New Year, Christmas sale or anything. So it's obvious that there is going to be a huge rise in the traffic. So you might need more web servers to handle that amount of requests, and you might even need a load balancers or maybe two to distribute that amount of traffic onto your web servers. And these changes, however, need to be made at a very short span of time. So after you've got the necessary hardware, you also need to provision them accordingly. And with configuration management, you can easily provision these new machines using either recipes or playbooks or any kind of script that configuration management uses. And also after the sale is over, you don't need that many web servers or a load balancer, so you can disable them using the same easy scripts as well. And also scaling down is very important when you are using cloud services. When you do not need any of those machines, it's no point in keeping them. So you have to scale down as well because you have to reconfigure your entire infrastructure as well. And with configuration management, it is a very easy thing to auto scale up and scale down your infrastructure. So I think you all have understood this problem and how configuration management solved it. So let us take a look at the third problem. The third problem was the work velocity of the developers were affected because the system administrators were taking time to configure the servers. After the developers have written a code, the next job is to deploy them on different servers like test servers and production servers for testing it out and releasing it. But then again, every server was managed by hand before, so the system administrators would again have to do the same thing, log into each server, configure them properly by making changes, and do the same thing again to all servers. So this was taking a lot of time. Now before DevOps came into the picture, there was already agility in the developers' end, for which they were able to release new softwares very frequently. But it was taking a lot of time for the system administrators to configure the servers for testing. So the developers would have to wait for all the test results, and this highly hampered the work velocity of the developers. But after there was configuration management, the system administrator had got access to a configuration management tool which allowed them to configure all the servers at one go. All they had to do is write down all the configurations and write down the list of all the softwares that they need to provision the servers and deploy it on all of the servers at one go. So now agility even came into the system administrators' end as well. So after configuration management, the developers and the system administrators were finally able to work in the same pace. Now this is how configuration management solved the third problem. Now let us take a look at the last problem. Now the last problem was rolling back. In today's scenario, everyone wants a change, and you need to keep making changes frequently because customers will start losing interest if things stay the same. So you need to keep releasing new features to upgrade your application. Even giants like Amazon and Facebook, they do it now and then, and still they're unsure if the users are going to like it or not. Now imagine if the users did not like it. They would have to roll back to the previous version again. So let's see how it creates a problem. Now before there was configuration management, let's say you've got the old version, which is the version 1, When you're upgrading it, you're changing all the configurations in the production server. You're deleting the old configurations completely and deploying the new version. Now, if the users did not like it, you would have to reconfigure this server again with the old configurations, and that will take up a lot of time. So your application is going to be down for that amount of time that you need for reconfiguring the server. And this might create a problem. But when you're using configuration management system, as you know that it documents every version of your infrastructure, when you're upgrading it with configuration management, it will remove the configurations of the older version, but it will be well documented. It will be kept there. And then the newer version is deployed. Now, if the users did not like it this time, the older configuration version was already documented. So all you have to do is just switch back to the old version. And this won't take up any time, and you can upgrade or roll back your application in zero downtime. Zero downtime means that your application would be down for zero time. It means that the users will not notice that your application went down, and you can achieve it seamlessly. And this is how configuration management system solved all the problems that was before. So guys, I hope that you've all understood how configuration management did that. So let us now move on to the next topic. Now the question is, how do I incorporate configuration management in my system? Well, you do that using configuration management tools. So let us take a look at all the available configuration management tools. So here I've got the 4 most popular tools that is available in the market right now. I've got Ansible and SolStack, which are a push-based configuration management tool. By push-based, I mean that you can directly push all those configurations onto your node machines directly. While Chef and Puppet are both pull-based configuration management tools, it means that they rely on a central server for configurations. They pull all the configurations from a central server. There are other configuration management tools available in the market too, but these 4 are the most popular ones. So now let's know more about Ansible. Now Ansible is a configuration management tool that can be used for provisioning, orchestration, application deployment, automation, and it's a push-based configuration management tool like I told you. What it does is that it automates your entire IT infrastructure and gives you large productivity gains. And it can automate pretty much anything. It can automate your cloud, your networks, your servers, and all your IT processes. So let us move on to the next topic. So now let us see the features of Ansible. The first feature is that it's very simple. It's simple to install and set up, and it's very easy to learn because Ansible playbooks are written in a very simple data serialization language which is known as YAML, and it's pretty much like English, so anyone can understand that, and it's very easy to learn. The next feature because of which Ansible is preferred over other configuration management tools is because it's agentless. It means that you do not need any kind of agents or any kind of client softwares to manage your node machines. All you have to do is install Ansible in your control machine and just make an SSH connection with your nodes and start pushing configurations right away. The next feature is that it's very powerful. Even though you call Ansible simple and it does not require any agent, it has the capabilities to model very complex IT workflows. And it comes with a very interesting feature which is called the batteries included. It means that you've got everything that you already need. And in Ansible, it's because it comes with more than 750 inbuilt modules, which you can use them for any purpose in your project. And it's very efficient because all the modules that Ansible comes with, they are extensible. It means that you can customize them according to your needs. And for doing that, you do not need to use the same programming language that it was originally written in. You can choose any kind of programming language that you're comfortable with and then customize those modules for your own use. So this is the power and liberty that Ansible gives you. Now let us take a look at the case study of NASA. What were the problems that NASA was facing and how Ansible solved all those problems? Now, NASA is an organization that has been sending men to the moon. They are carrying out missions in Mars, and they're launching satellites now and then to monitor the Earth. And not just the Earth, they are even monitoring other galaxies and other planets as well. So you can imagine the kind and the amount of data that NASA might be dealing with. But all the applications were in a traditional hardware-based data center, and they wanted to move into a cloud-based environment because they wanted better agility and they wanted better adaptive planning for that. And also they wanted to save costs because a lot of money was spent on just the maintenance of the hardware. And also they wanted more security because NASA is a government organization of the United States of America, and obviously they wanted more security because NASA is a government organization of the United States of America, and they hold a lot of confidential details as well for the government. So they just cannot always rely on the hardware to store all these confidential files. They needed more security because if at any time the hardware fails, they cannot afford to lose that data. And that is why they wanted to move all their 65 applications from a hardware environment to a cloud-based environment. Now let us take a look what was the problem. Now for this migration of all the data into a cloud environment, they contacted a company called Infozen. Now Infozen is a company who is a cloud broker and integrator who implements solutions to meet needs with security. So Infozen was responsible for making this transition. And NASA wanted to make this transition in a very short span of time. So all the applications were migrated as it is into the cloud environment. And because of this, all the AWS accounts and all the virtual private clouds that was previously defined, they all got accumulated in a single data space, and this made up a huge chunk of data. And NASA had no way of centrally managing it. And even simple tasks like giving a particular system administrator access rights to a particular account, this became a very tedious job. Well, NASA wanted to automate end-to-end deployment of all their apps, and for that they needed a management system. So this was the situation when NASA moved into the cloud. So you can see that all those AWS accounts and virtual private clouds, they got accumulated and made a huge chunk of data, and everyone was accessing directly to it. So there was a problem in managing the credentials for all the users and the different teams. What NASA needed was divide up all their inventories, all their resources into groups and number of hosts, and also they wanted to divide up all the users into different teams and give each team different credentials and permissions. And also if you look in the more granular level, each user in each team could also have different credentials and permissions. Let's say that you want to give the team leader of a particular team access to some kind of data while you don't want the other users in the team to access that data. So also NASA wanted to define different credentials for each individual member as well. They wanted to divide up all the data according to the projects and jobs also. NASA wanted to move from chaos into a more organized manner. And for that, they adopted Ansible Tower. Now, Ansible Tower is Ansible in a more enterprise level. Ansible Tower provides you with a dashboard which provides all the status summary of all the host and job. Now, Ansible Tower is a web-based interface for managing your organization. It provides you with a very easy-to-use user interface for managing quick deployments and monitoring all the configurations. So let's see what Ansible Tower did. It has the credential management system which could give different access permission to each individual user and teams. And also it divided up the user into teams and single individual users as well. And it has a job assignment system, and you can also assign jobs using Ansible Tower. You suppose, let's say that you have assigned job 1 to a single user, job 2 another single user, while job 3 could be assigned to a particular team. Similarly, the whole inventory was also managed. All the servers, let's say, dedicated to a particular mission was grouped together, all the host machines and other systems as well. So Ansible Tower helped NASA to organize everything. Now let us take a look at the dashboard that Ansible Tower provides us. So this is the screenshot of the dashboard at a very initial level. You can see right now there are 0 hosts, nothing is there, but I'm just showing you what Ansible Tower provides you. So on the top you can check all the users and teams. You can manage the credentials from here. You can check your different projects and inventories. You can make job templates and schedule jobs as well. So this is where you can schedule jobs and provide every job with a particular ID so that you can track it. You can check your job status here, whether your job was successful or failed. And since Ansible Tower is a configuration management system, it will hold the historical data as well. So you can check the job statuses of the past month or the month before that. You can check the host status as well. You can check how many hosts are up and running. You can see the host count here. So this dashboard of Ansible Tower provides you with so much ease of monitoring all your systems. So it's very easy to use Ansible Tower dashboard. Anyone in your company, anyone can use it because it's very user friendly. Now let us see the results that NASA achieved after it has used Ansible Tower. Now updating nasa.gov used to take 1 hour of time, and after using Ansible it got down to just 5 minutes. Security patching updates were a multi-day process, and now it requires only 45 minutes. The provisioning of OS accounts can be done in just 10 minutes. Earlier, the application stack-up time required 1 to 2 hours, and now it's done in only 10 minutes. It also achieved near real-time RAM and disk monitoring and baselining all the standard Amazon machine images. This used to be a 1 hour manual process, and now you don't even need manual interference for that. It became a background invisible process. So you can see that how Ansible has drastically changed the overall management system of NASA. So guys, I hope that you've understood how Ansible helped NASA. If you have any question, you may ask me at any time on the chat window. So let us proceed to the next topic. Now this was all about how others have used Ansible. So now let us take a look at the Ansible architecture so that we can understand more about Ansible and decide how we can use Ansible. So this is the overall Ansible architecture. I've got the Ansible automation engine, and I've got the inventory and a playbook inside the automation engine. I've got the configuration management database here and host. And this configuration management database is a repository that acts as a data warehouse for all your IT installations. It holds all the data relating to the collection of your all IT assets. And these are commonly known as configuration items. And it also holds the data which describe the relationships between such assets. So this is a repository for all your configuration management data. And here I've got the Ansible automation engine. I've got the inventory here, and inventory is nothing but the list of all the IP addresses of all my host machines. Now, as I told you how to use configuration management, you use it with the configuration management tool like Ansible. But how do you use Ansible? Well, you do that using playbooks. And playbooks describe the entire workflow of your system. Inside playbooks, I've got modules, APIs, and plugins. Now, modules are the core files. Now, playbooks contain a set of plays, which are a set of tasks. And inside every task, there is a particular module. So when you run a playbook, it's the modules that actually get executed on all your node machines. So modules are the core files. And like I told you before, Ansible already comes with inbuilt modules which you can use, and you can also customize them as well. It comes with different cloud modules, database modules, and don't worry, I'll be showing you how to use those modules in Ansible. And there are different APIs as well. Well, APIs in Ansible are not meant for direct consumption. They're just there to support the command line tools. For example, they have the Python API, and these APIs can also be used as a transport for cloud services, whether it's public or private, you can use it. Then I've got plugins. Now plugins are a special kind of module that allow to execute Ansible tasks as a job build step. And plugins are pieces of code that augment the Ansible's core functionality. And Ansible also comes with a number of handy plugins that you can use. For example, you have action plugins, cache plugins, callback plugins. And also you can create plugins of your own as well. Now let me tell you how exactly different it is from a module. Let me give you the example of action plugin. Now action plugin are front-end modules, and what it does is that when you start running a playbook, something needs to be done on the control machine as well. So these action plugins trigger those action and execute those tasks in the controller machine before calling the actual modules that are getting executed in the playbook. And also you have a special kind of plugin called the connection plugin, which allows you to connect to the Docker containers in your node machine and many more. And finally, I have this host machine that is connected via SSH, and these host machines could be either Windows or Linux or any kind of machines. And also let me tell you that it's not always needed to use SSH for connection. You can use any kind of network authentication protocol. you can use Kerberos, and also you can use the connection plugins as well. So this is fairly a very simple Ansible architecture. So now that you've understood the architecture, let us write a playbook now. Now let me tell you how to write a playbook. And playbooks in Ansible are simple files written in YAML code. And YAML is a data serialization language. You can think of data serialization language as a translator for breaking down all your data structure and serialize them in a particular order, which can be reconstructed again for later use. And you can use this reconstructed data structure in the same environment or even in a different environment. So this is the control machine where Ansible will be installed, and this is where you'll be writing your playbooks. So let me show you the structure of how to write a playbook. Now every playbook starts with 3 dashes on the top. So first you have to mention the list of all your host machines here. It means where do you want this playbook to run. Then you can mention variables by gathering facts. Then you can mention the different tasks that you want. Now remember that the tasks get executed in the same order that you write them. For example, if you want to install software A first and then software B later on, so make sure that the first task would be install software A and the next task would be install software B. And then I've got handlers at the bottom. The handlers are also tasks, but the difference is in order to execute handlers, you need some sort of triggers in the list of tasks. For example, we use notify. I'll show you an example now. Okay, let me show you an example of playbook so that you can relate to this structure. So this is an example of an Ansible playbook to install Apache. Like I told you, it starts with 3 dashes on the top. And remember that every list starts with a dash in the front or a hyphen. Here I've only mentioned just the name of one group. You can mention the name of several groups where you want to run your playbook. Then I've got the tasks. You give a name for the task, which is install Apache, and then you use a module. Here I'm using the apt module to download the package. So this is the syntax of writing the apt module. So you give the name of the package, which is Apache 2. Update cache is equal to yes. So it means that it will make sure that apt-get is already updated in your node machine before it installs the Apache 2. And you mention state equal to latest. It means that it will download the latest version of Apache 2. And this is the trigger because I'm using handlers here, right? And the handler here is to restart Apache, and I'm using the service module here. And the name of the software that I want to restart is Apache 2, and state is equal to restart it. So in Notify I've mentioned that there is going to be a handler whose job would be to restart Apache 2. And then the task in the handler would get executed and it will restart Apache 2. So this is a simple playbook, and we'll also be writing similar kind of playbooks later on the hands-on part. So you'll be learning again. So if it's looking a little gibberish for you, we'll be doing that on the hands-on part, so then it'll clear all your doubts. So now let us see how to use Ansible and understand its applications. So we can use Ansible for application deployment, configuration management, security and compliance, provisioning, and orchestration. So let us take a look at them one by one. First, let us see how we can use Ansible for orchestration. Well, orchestration means, let's say that we have defined configurations for each of my systems, but I also need to make sure how these configurations will interact with each other. So this is the process of orchestration where I decide that how the different configurations on different of my systems and my infrastructure would interact with each other in order to maintain a seamless flow of my application. And your application deployments need to be orchestrated, because you've got a front end and back end services, you've got databases, you've got monitoring, networks, and storage, and each of them has their own role to play with their configuration and deployment. And you cannot just run all of them at once and expect that the right thing happens. So what you need is that you need an orchestration tool that all these tasks happen in the proper order, that the database is up before the backend server and the front-end server is removed from the load balancer before it gets upgraded, and that your networks would have their proper VLANs configured. So this is what Ansible helps you to do. So let me give you a simple example so that you can understand it better. Let's say that I want to host a website on my node machines, and this is precisely what we're going to do later on the hands-on part. So first, and in order to do that, first I have to install the necessary software, which is the LAMP stack. and after that I have to deploy all the HTML and PHP files on the web server. And after that I'll be gathering some kind of information from my web pages that will go inside my database server. Now if you want to perform these all tasks, you have to make sure that the necessary softwares are installed first. Now I cannot deploy the HTML and PHP files on the web servers if I don't have a web servers, if Apache is not installed. So this is orchestration, where you mention that the task that needs to be carried out before and the task that needs to be carried out later. So this is what Ansible playbooks allow you to do. Now let's see what provisioning is. Like provisioning in English means to provide with something that is needed, it is same in case of Ansible. It means that Ansible will make sure that all the necessary softwares that you need for your application to run is properly installed in each of the environments of your infrastructure. So let us take a look at this example here to understand what provisioning actually is. Now if I want to provision a Python web application that I'm hosting on Microsoft Azure, and Microsoft Azure is very similar to AWS, and it is also a cloud platform on which you can build up all your applications. So let's say, now if I want to host if I'm developing a Python web application, for coding I would need the Microsoft Azure document database, I would need Visual Studio, would need to install Python also, and some kind of software development kit and different APIs for that. So Ansible, so you can list out the name of all the software development kits and all these necessary softwares that you will require for coding this web, that you would require in order to develop your web application. So you can list out all the necessary softwares that you'd be needing in an Ansible playbook in order to develop your web application. And for testing your code out, you will again need Microsoft Azure document database, you would again need Visual Studio and some kind of testing software. So again, you can list out all the softwares in the Ansible playbook, and it will provision your testing environment as well. And it's the same thing while you're deploying it on the production server as well. Ansible will provision your entire application at all stages, at coding stage, at testing, and at the production stage also. So guys, I hope you've understood what provisioning is. Let us move on to the next topic and see how we can achieve configuration management with Ansible. Now, Ansible configurations are simple data descriptions of your infrastructure, which is both human readable and machine parsable. And Ansible requires nothing more than an SSH key in order to start managing systems, and you can start managing them without installing any kind of agent or client software. So you can avoid the problem of managing the management, which is very common in different automation systems. For example, I've got my host machines and Apache web servers installed in each of the host machines. I've also got PHP and MySQL installed. Now if I want to make configuration changes, if I want to update Apache and update my MySQL, I can do it directly. I can push those new configuration details directly onto my host machines or my node machines and my server. And you can do it very easily using Ansible playbooks. So let us move on to the next topic, and let us see how application deployment has been made easier with Ansible. Now, Ansible is the simplest way to deploy your applications. It gives you the power to deploy all your multi-tier applications very reliably and consistently. And you can do it all from a common framework. You can configure all the needed services as well as push application artifacts from one system. With Ansible, you can write playbooks, which are the description of the desired state of your system, and it is usually kept in the source control. So Ansible then does all the hard work for you to get your systems to the state, no matter what state they are currently in. And playbooks make all your installations, all your upgrades for day-to-day management very repeatable. So with Ansible, you can write playbooks, which are the descriptions of the desired state of the systems, and these are usually kept in the source control. Ansible then does all the hard work for you to get all your systems in the desired state, no matter what state they are currently in. And playbooks make all your installations, your upgrades, for all your day-to-day management in a very repeatable and reliable way. So let's say that I'm using a version control system like Git while I'm developing my app. And also I'm using Jenkins for continuous integration. Now Jenkins will extract code from Git every time there is a new commit and then make a software build. And later this build will get deployed in the test server for testing. Now, if changes are kept making in the code base continuously, you would have to configure your test and the production server continuously as well according to the changes. So what Ansible does is that it continuously keeps on checking the version control system here so that it can configure the test and the production server accordingly and quickly. And hence it makes your application deployment like a piece of cake. So guys, I think you have understood the application deployment. Don't worry, in the hands-on part, we'll also be deploying our own applications on different servers as well. Now let us see how we can achieve security with Ansible. In today's complex IT environment, security is paramount. You need security for your systems, you need security for your data, and not just your data, your customers' data as well. Not only you must be able to define what it means for your systems to be secure, you also need to be able to simply apply that security. And also you need to constantly monitor your systems in order to ensure that they remain compliant with that security. And with Ansible, you can simply define security for your systems using playbooks. With playbooks, you can set up firewall rules, you can lock down different users or groups, and you can even apply custom security policies as well. Now Ansible also works with the Mindpoint group, which writes Ansible roles to apply DSA-STIG. Now DSA-STIG is a cybersecurity methodology for standardizing security protocols within your network, servers, and different computers. And also it is very compliant with the existing SSH and WinRM protocols. And this is also a reason why Ansible is preferred over other configuration management tools. And it is also compatible with different security verification tools like OpenSCAP and Stigma. What tools like OpenSCAP and Stigma does is that it carries out a timely inspection of all your software inventory and check for any kind of vulnerabilities. And it allows you to take steps to prevent those attacks before they actually happen. And you can apply this security over your entire infrastructure using Ansible. So how about some hands-on with Ansible? So let us write some Ansible playbooks now. So what we're going to do is that we're going to install LambStack, and then we're going to host a website on the Apache server, and we'll also collect some data from our web page and store it in the MySQL server. So guys, let's get started. So here I'm using the Oracle VirtualBox Manager, and here I've created two virtual machines. The first is the Ansible control machine and the Ansible host machine. So Ansible control machine is the machine where I have installed Ansible, and this is where I'll be writing all my playbooks. And Ansible host 1 here is going to be my node machine. This is where the playbooks are going to get deployed. So in this machine I'll deploy my website. So I'll be hosting my website in the Ansible host 1. So let us go to my control machine and start writing the playbooks. So this is my Ansible control machine. Now let's go to the terminal first. So this is the terminal of my Ansible control machine. And now I've already installed Ansible here, and I've already made an SSH connection with my node machine. So let me here just become the root user first. Now you should know that you do not always need to become the root user in order to use Ansible. I'm just becoming the root user for my convenience because I like to get all the root privileges while I'm using Ansible. But you can sudo to any user if you like. So let me clear my screen first. Now before we start writing playbooks, let us first check the version of Ansible that is installed here. And for that I'll just use the command ansible --version. And as you can see here that I have got the Ansible 2.2.0.0 version here. Now let me show you my host inventory file. Since I've got only one node machine here, so I'm going to show you where exactly the IP address of my node machine is being stored. So I'll open the host file for you now. So I'm just going to open the file and show it to you. So I'm using the gedit editor, and the default location of your host inventory file is etc ansible/hosts. And this is your host inventory file. And now I have mentioned the IP address of my host machine here, which is 192.168.56.102. And I have named it under the group name test servers. So always write the name of your group under the square brackets. Now I just have one node machine, so there is only one IP address. If you have many node machines, you can just list down the IP address under this line. It's as simple as that. Or if you even want to group it under a different name, you can use a different name, use another square bracket and put a different name for another set of your hosts. Okay, now let me clear my screen first. So first let me just test out the SSH connection, whether it's working properly or not using Ansible. So for that I'll just type in the command Ansible and ping, and then the name of the group of my host machines, which is test servers in my case. And ping changed to pong. It means that an SSH connection is already established between my control machine and my node machine. So we are all ready to write playbooks and start deploying it on the nodes. So the first thing that I need to do is write a provisioning playbook. Now since I'm going to host a website, I would first need to install the necessary softwares. So I'll be writing a provisioning playbook for that. And I'll provision my node machine using LambStack. So let us write a playbook to install LambStack on my node machine. Now I've already written that playbook, so I'm just going to show it to you. So I'm using the gedit editor again, and the name of my provisioning playbook is LambStack. And the extension for a YAML file is .yml. And this is my playbook. Now let me tell you how I have written this playbook. As I told you that every playbook starts with 3 dashes on the top, so here are the 3 dashes, and then I've given a name to this playbook, which is to install Apache, PHP, and MySQL. Now I've already got the L in my LAMP because I'm using a Ubuntu machine, which is a Linux operating system. So I need to install Apache, PHP, and MySQL now. And then you have to mention the host here on which you want this playbook to get deployed. So I've mentioned test servers here, and then I want to escalate my privileges, for which I'm using become and become user. It is because sometimes you want to become another user different from what you are actually logged into the remote machine. So you can use escalating privileges tools like su or sudo to gain root privileges. And that is why I've used become and become user for that. So I'm becoming the user root. And I'm using become true here on the top. What it does is that it activates your privilege escalation. And then you become the root user on the remote machine. And then gather facts true. Now what it will do is that it will gather useful variables about the remote host. Now what exactly it will gather is some sort of files or some kind of keys which can be used later in a different playbook. And as you know that every playbook is a list of tasks that you need to perform. So this is the list of all my tasks that I'm going to perform. And since it's a provisioning playbook, which means I'm only installing the necessary softwares that will be needed in order to host a website on my node machine. So first I'm installing Apache. So I've given the task name as install Apache 2. And then I'm using the package module here. And this is the syntax of the package module. So you have to first specify the name of the package that you're going to download, which is Apache 2. And then you put state equal to present. Now since you're installing something for the first time and you want this package to be present in your node machine, so you're putting state equal to present. Now similarly, if you want to delete something, you can put state equal to absent, and it works that way. So I've installed an Apache PHP module, and I've installed PHP client, PHP encrypt, PHP GD library. I've installed a package PHP MySQL, and finally I've installed the MySQL server in the similar way that I've installed Apache 2. And this is a very simple playbook to provision your node machine, and actually all the playbooks are simple. So I hope that you have understood how to write a playbook. Now let me tell you something that you should always keep in mind while you are writing playbooks. Make sure that you are always extra careful with the indentation, because YAML is a data serialization language and it differentiates between elements with different indentations. For example, I've got a name here and a name here also, but you can see that the indentations are different. It is because this is the name of my entire playbook while this is just the name of my particular task. So these two are different things and they need to have different indentations. The ones with the similar indentations are known as siblings. Like this one, this is also doing the same thing, this is also installing some kind of package, and this is also installing some kind of package. So these are similar. So that's why you should be very careful with indentation, otherwise it will create a problem for you. So what are we waiting for? Let us run this playbook. Clear my screen first. So in order to run a playbook, and the command that you should be using to run an Ansible playbook is ansible-playbook, and then the name of your file, which is lambstack.yaml. And here we go. And here it is okay because it is able to connect to my node machine. Apache 2 has been installed. And it's done. My playbook is successfully run. And how do I know that? I know that seeing these common return values. So these common return values like OK, changed, unreachable, and failed, they give me the status summary of how my playbook was run. So OK equal to 8, it means there were 8 tasks that was run OK. Changed equal to 7, it means that something in my node machine has been changed because obviously I've installed new packages into my node machine. So it's showing changed equal to 7. Unreachable is equal to 0, it means that there were 0 hosts that were unreachable. And failed equal to 0, it means that 0 tasks were failed. So my playbook was run successfully onto my node machine. So let us check my node machine and see if Apache and MySQL has been installed. So let us go to my node machine now. So this is my node machine. So let us check now if Apache server has been installed. So I'm going to my web browser. So this is my web browser in my node machine. So let me go to the local host and check if Apache web server has been downloaded. And it's there. It works. Now this is the default web page of Apache 2 web server. So now I know for sure that Apache was installed in my node machine. Now let us see if MySQL server has been installed. Let me go to my terminal. This is the terminal of my node machine. Now if you want to check if MySQL is installed, just use this following command. MySQL user is root and then -p. Sudo password again for MySQL, and there it is. So MySQL server was also successfully installed in my node machine. So let's go back to my control machine and let's do what is left to do. So we're back into our control machine. Now I've already provisioned my node machine. So let us see what we need to do next. Now since we are deploying a website on the node machine, let me first show you how my first web page looks like. So this is going to be my first web page, which is index.html, and I've got 2 more PHP files also. So I'll be actually deploying these files onto my node machine. So let me just open the first web page to you. So this is going to be my first web page, and what I'm going to do is that I'm going to ask for name and email because this is a registration page for Edureka where you have to register with your name and email, and I want this name and email to go into my database. So for that I need to create a database, and I also need to create a table for this name and email data to store into. So for that we'll write another playbook, and we'll be using database modules in that. Clear the screen first. Now again, I've already written that playbook, so let me just show it to you. So I'm using the gedit editor here again, and the name of this playbook is MySQL module. Okay, so this is my playbook. So like all playbook, it starts with 3 dashes, and here I have mentioned host all. Now I just have only one host. I know I could have mentioned either the only one IP address directly or even given the name of my group, but I've written just all here so that you can know that if you had many group names or if you have many nodes and you want this playbook to run on all of your node machines, you can use this all, and this playbook will get deployed on all your node machines. So this is another way of mentioning your hosts, and I'm using remote user root, and this is another method to escalate your privileges. It's similar to become and become user, so on the remote user to have root privileges while this playbook would run. And then the list of the tasks. And so what I'm doing in this playbook is that since I have to connect to my MySQL server, which is present in my node machine, I need a particular software for that, which is the MySQL Python module. And I'm going to download and install it using pip. Now pip is a Python package manager with which you can install and download Python packages. But first I need to install pip in my node machine. So since I told you that the task that you write in a playbook, it gets executed in the same order that you write them. So my first task is to install pip, and then I'm using the apt module here. Here I've given the name of the package, which is Python pip, and state equal to present. And after that I'm installing some other softwares using pip, and I'm installing some other related softwares as well. I'm also installing library MySQL client dev, and after that using pip I'm installing the MySQL Python module. Now notice that, so you can consider this as an orchestration playbook because here I'm making sure that pip has to get installed first, and after pip is installed, I'm using pip to install another Python package. So you see what we did here, right? And then I'm going to use the database modules for creating a new user to access the database, and then I'm creating the database named edu. So for creating a MySQL user, I have used the MySQL user database module that Ansible comes with, and this is the syntax of the MySQL user module. Here you create the name of the new user, which is edureka. You mention the password, and the priv here, it means what privileges do you want to give it to the new user. And here I'm granting all privileges for all database. And since you're creating it for the first time and you want state to be present. Similarly, I'm using the MySQL DB module to create a database in my MySQL server named edu. So this is the very simple syntax of using MySQL DB module, where you have to just give the name of the database in DB equal to and state equal to present. So this will create a database named edu. And after that, I also need to create a table inside the database for storing my name and email details, right? And unfortunately, Ansible does not have any MySQL table creating modules. So what I did is that I've used the command module here. And with command module, I'm directly going to use MySQL queries to create a table. And the syntax is something like this. So you can write it down or remember it if you want to use it. So for that, since I'm writing a MySQL query, I'll start it with MySQL user edureka. The hyphen U is for the user. And then for password, it's edureka. And after hyphen E, just write the query that you need to execute on the MySQL server and write it in single quotations. So I've written the query to create a table, and this is create table reg, the name, the email, and then after that just mention the name of the database on which you want to create this table, which is edu for me. So this is my orchestration playbook. Clear my screen first. The command is Ansible -playbook and the name of your playbook, which is MySQL module. And here we go. So again, my common return values tell me that the playbook was run successfully because there are no failed tasks and no unreachable hosts. And there are change tasks in my node machine. So now all the packages are downloaded. Now my node machine is well provisioned. It's properly orchestrated. Now what are we waiting for? Let's deploy our application. Well, I'll clear the screen first. So now let me tell you what exactly do we need to do in order to deploy my application. And in my case, these are just 3 PHP files and HTML files that I need to deploy it on my node machine. In order to display these HTML files and PHP files on my web server in my node machine, what I need to do is that I need to copy these files from my control machine to the proper location in my node machine. And we can do that using playbooks. So let me just show you the playbook to copy files. And the name of my file is deploy website. So this is my playbook to deploy my application. And here again I've used the 3 dashes, and then the name of my playbook is copy. The host, as you know, that it's going to be test servers. I'm using privilege escalation again, and I'm using become and become user again. Then gather facts again, true. And here is the list of the tasks. And the task is to just copy my file from my control machine and paste it in my destination machine, which is my node machine. And for that, and for copying, I've used the copy module. And copy module is a file module that Ansible comes with. So this is the syntax of the copy module. Here you just need to mention a source. And source is the path where my file is contained in my control machine, which is home, edureka, documents, and the name of the file is index.html. And I want it to go to var www html and it's index.html. So I should be copying my files into this location in order for it to display it on the web page. And similarly, I've copied my other PHP files using the same copy module. I've mentioned the source and destination. I'm copying them to the same destination from the same source. So I don't think any of you would have questions here. This is the most easiest playbook that we have written today. So let us deploy our application now. And for that we need to run this playbook, and before that we need to clear the screen because there are a lot of stuff on our screen right now. So let's run the playbook. And here we go. And it was very quick because there was nothing much to do. You just had to copy files from one location to another. And these are very small files. So let us go back to our host machine and see if it's working. So we're back again at our host machine. So let's go to my web browser to check that. So let me refresh it. And there it is. And so here is my first web page. So my application was successfully deployed. So now let us enter our name and email here and check if it is getting entered in my database. So let's put our name and the email, xyz.com, and add it. So new record created successfully. It means that it is getting inserted into my database. Now let's go back and view it. And there it is. So congratulations, you have successfully written playbooks to deploy your application. You've provisioned your node machines using playbooks and orchestrated them using playbooks. Now, even though at the beginning it seemed like a huge task to do, Ansible